Hi everyone, this is my capstone project called Let's Swing. So if you take a walk into my backyard, you would notice that our family really likes to swing. So we wanted to find out what the differences between these swings were. So how is a swing like a pendulum? That's my overall question. And a pendulum is an object hung from a fixed point that swings freely back and forth under the action of gravity, and it is supported by chains that are attached to fixed points at the top of the swing set. It continues to swing back and forth until until friction slows it down. So to get started, I gathered my materials, which was this notebook, a tape measure to see how long everything was, and my sensor tag. I have my worksheet that I created, and I set up my swings to the appropriate height. Now, since I don't have access to a printer right now since I'm on sabbatical, I am just going to show you what the worksheet looked like. So here we go. Basically, I just went through the background like I had just shared with you about, what a pendulum is, our essential questions, how is a swing like a pendulum, how does the length of a pendulum affect the speed or the acceleration. I shared some vocabulary. And then right here is the chart that I would have the students fill out for their data. There are reflection questions. Look at this pendulum. How does this compare to the swings on the playground? What conclusion can you make about the relationship between the length and the acceleration? And then I included a few variations if students wanted to extend their learning. So this is what we did. So this was my daughter, Piper. She helped me out with it. So the first one she went on had a length of 68 inches. And she had an average acceleration of 3 meters per second squared. The second swing she went on was a little higher, so it was a shorter length, and that was 56 inches long, and she had an average acceleration of 5.4 meters per second squared. I'm going to share this video. There is no sound because I did not spend more on the screencast. So it wasn't able to share the audio, but if you want to watch it later, you would be able to listen to it. But basically, it is just her talking about what she liked about the swing. And when I asked her which one she preferred, she said she likes the one that is longer because it goes slower. So anyway, you can take a look at that if you would like. Okay, and just for fun, we wanted to continue our investigation and take a look at our horse swing that we have. This horse swing dangles 14 feet, and she had an average acceleration of 1 meter per second. The rainbow swing, it's just a hammock swing, dangles 19 feet. That should be feet instead of inches. And that has an average acceleration of negative 1.3 meters per second. So our conclusion is the longer the pendulum, the lower the acceleration, which makes sense. The further you pull it back, the longer it takes to go within a period, which is from the start to the stop. Here's a graph that just illustrates that. Looking at the levels of inquiry, I felt that students would be following a specific procedure to solve the problem. So I felt that would be the structured inquiry level. And that's it. Thank you so much for listening.